Second last chapter on algebra. It's taken a bit longer than I thought. I thought it might only take 8 weeks to get through algebra. It's going to take about 10 because there's so much in it. Is that right? But in first year in fifth year, the main topics you cover are trig and algebra. We'll definitely get them done, and I hope to get coordinate geometry done as well. But there's so much in algebra, it literally is a whole book nearly in itself. There's so much in it. Right, so, inequalities. The only thing that's left in algebra after inequalities is logs and ellipses. So they can be together. That's generally the hardest bit. This is kind of the last of the okay-ish. So, with this, how are you on that? Right, with inequalities, so we have, first of all, I'm going to go for definite, the sign. So, not equal, less than or equal to, greater than or greater than or equal. Is that okay? So they are the signs first of all. And equals with a line going through it, not equal. And x with a less than means x less than, and x with a less than or equal sign under is less than or equal to, and x with a greater than sign is x greater than, and a greater than or equal to. So your basic rules of inequalities. The next little bit is the big rule with inequalities is multiply across by a negative number, sign flips. Alright, big rule with inequalities is multiply across by a negative number, the sign flips. And there's a reason for this. I.e., we know 5 is greater than minus 3, isn't it? But if you multiply 2 of them by minus 1, you get minus 5 and 3. Which one is now bigger? 3. So that's why when we're doing algebra, it changes everything. That's why it's very important that the sign you flip the sign. So for example, take here, 14 minus 3x is greater than or equal to 2. Move the 14 over to the right, you get minus 3x is greater than or equal to 2 minus 14. Minus 3x is greater than or equal to minus 12. Divide both sides by minus 3.
Can you just change the sign there?
You can change the sign there if you want.
Like you don't really have to.
Well, you have to divide by minus 3 to get x on its own end. So then x then is less than or equal to 4. So the sign was going that way, but it flips. Is that alright? Right, off you go. Start with the basics first of all. Get an answer here. And graph. Get an answer and graph. We're looking to get x on its own.
So when you take it off the outside
The sign changes. Same as well. And graph. So I am number 9. Let's get either Kieran or Johnny and go back to that was. Right, let's look at it. So, x is to one side, number is the other. So that's 8x minus 3x, and 9 plus 1, that's 5x is less than 10. X divided across by 5. Sign obviously doesn't fit this thing, so divided by 5. X is less than 2. This is obviously just basics. First of all, graph it. Now, when you're graphing it, number down the middle, all the numbers less than 2. Why do I shade it in? Why did I put dots? Why did I shade it in? Not rational close, real. Real numbers, you shade it in. Don't forget that. What do I do for z and n? Dots. Put dots in the numbers. Last little bit in this. Why didn't I include 2? Why did I sort around 2? Because it's less than. When will I include 2 in this situation? If there's a line underneath, exactly. Right, off you go. This is all basics. Let's just introduce ourselves to it. double inequality. Off we go and solve this one. This is still Jewish circle. There's two ways of doing this. Right. Let's look at it. So, first way of solving this is like following. Section 1, section 2, section 3. Anything we do to one section, we must do to the other two. So, I want to get rid of the 3 out of the middle, because I want to just x in the middle. So if I get rid of 3 here, I take away 3 here, here, and here. And you do to one section, you must do to the other two. You're then left with 5x, those two cancel, they give minus 7 minus 3, which is minus 10, and 18 minus 3, which is 15. Divide across by 5 because you want to get x on its own. You get left with x less than 3 and x greater than or equal to minus 2. Now, the problem with that way is that's the way a lot of people will be taught in Junior. It doesn't always necessarily work. So, for example, at leaving cert level, you could have the following. Now we run into a problem. Because, just say for example, you want to move your x into the middle. So to move your x into the middle, you can put minus 2x over here, minus 2x over here, minus 2x over here. It's not here, but you end up putting it over there. So you run into a wall. You see that? So that's not always the best way to do it. That's the way we move on Junior Cert. The way that leaving cert though, to make sure that you don't run into this problem, I'll show you the exact same question until we got the same answer. 5x plus 3 is less than 18 and greater than or equal to minus 7. You split it into 2. So I will come out here like this, and come out here like this. You're going to say minus 7 less than or equal to 5x plus 3, and you're going to say 5x plus 3 is less than 18. See the way I take the same thing and split it into 2. Took the middle and went left, took the middle, is everyone with me there? Then it's just simply minus 7 bring over 3 minus 3 less than or equal to 5x. Less than or equal to 5x minus 10 divided across by 5. X is greater or equal to minus 2. Over here, 5x less than 18 minus 3. 5x less than 15. X less than 3. There's your two answers. Put the two of them in together. 3 and greater or equal. You get the same answer. Is that alright? I want you to have a go at an example of these. So, have a go at the following. I want you to do the second way instead of the first way. I want you to do it like this. I'll go this way. Off we go. Now want you to solve it, and I want you to graph it. Figure out what you saw. Deciding after. Absolutely. You can hear it. One more minute. Right, have a little look at it. So, split it out into two. Out here and out here. Minus 33 less than or equal to 7x minus 5. 7x minus 5 less than or equal to minus 12. That is minus 33 plus 5 less than or equal to 7x. That's minus 28 less than or equal to 7x divided across by 7. Minus 4 is less than or equal to x over here. 7x less than or equal to minus 12 plus 5. 7x less than or equal to minus 12 plus 5 is minus 7. X is less than or equal to minus 1. We draw our graph. Don't forget, if this is a 10-mark question, that's only 7. Here's your final 3. You have to draw your graph. We're going from minus 1 to minus 4. So here's minus 1, minus 2, minus 3, minus 4. Now, am I putting dots or am I shading in? Shading in because it's R. When it's R, you shade. When it's N or Z, you put dots. Am I including minus 1? Yeah, because there's a line underneath it. Am I including minus 2? Yeah, minus 3 and minus 4. You include the 4. Is that alright? Very important. Right, there is another way they can ask this question, which is a small bit more wordy, and I want us to have a go at it now. So, another type of double inequality for all the world is when it comes up like the following. Solve for n and n and graph the solution n intersection n where x is n to the bar. They have 4 minus x is less than or equal to 6. N is 3x minus 1 less than or equal to x plus 9, where both of them are x and n to the bar. What do you reckon you want us to do here? Exactly. Both here perfectly right. Solve n, and then put them together. So it's the same question as over here. Except what they don't, they've already split it. Is that alright? They've already split them up. So they want you to solve this one on its own, solve this one on its own, and then graph the two of them on the same line. Look, two ends together. So off you go, get x up, get a value for x here, get a value for x here, and put them all on the graph. Is that okay? Off you go. Anyone who's confused, give me a shout. You're getting the value for x on the top, x on the bottom, and putting them together.
What's the XE
Means it's an element of real numbers. So that tells you whether it's a shade or dots going on. Divide 1 minus 1 or multiply by 1. So, with this one, it's 4 minus x is less than or equal to 6, and 3x minus 1 is less than or equal to x plus 9. So on the left, that's minus x is less than or equal to 6 minus 4, minus x is less than or equal to 2, I don't want minus x and 1, plus x. So I multiply or divide by minus 1, whichever way you want to say it. Sign flips. Don't forget to flip your sign. Over here then, I have 3x minus x, because I bring this x over minus 1 comes over plus. That's 2x is less than or equal to 10. X is x is less than or equal to 5. Down onto your graph, put them together. Now, you gotta put them together so to make sure the signs are going the right way. So you got to put this sign over here with a 5, and this has to be greater than or equal to minus 2. So it has to look a bit like this. Less than or equal to 5 and minus 2. Is that okay? So there's your line between 5 and minus 2, and you include the both of them, because the reason we include the both of them is line under both sides. Happy with that? We're going to do one more of these, we'll jump back. As I said, this is all still technically junior stuff. Have a go at this one for me. By the way, next week we're doing exam paper questions on everything we've done so far in algebra. So before we do the last chapter, we're going to do a revision class next week, and we're going to do it via doing exam paper questions. Alright? Off you go. Have a go at this one. So anyone who wants to do a bit of revision for next week's class is over. We've done the last 8 weeks. I advise you to do it for this video class. Right, let's have a little look at it then. So, 2x plus 7 less than or equal to 19 is 2x less than or equal to 19 minus 7. 2x is less than or equal to 19 minus 7, which is 12. X is less than or equal to 6. Then 3 minus 2x is less than 11. Minus 2x is less than 11 minus 3. Minus 2x is less than 11 minus 3, which is 8. Divide both sides by minus 2. X is less than minus 4. We happy with those two? Right. You're dead right. Come on, Louis. At least one of us is paying attention. X is greater than minus 4. That means that we want x to be greater than minus 4, and we want it to be less than or equal to 6, or it's the exact same thing as saying that less than or equal to 6 and greater than minus 4. Either one of those. As long as you have the signs the correct way next to the numbers, you're grand. Draw your line. Draw your numbers 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, and minus 4. Right. Are we putting dots or are we shading it in? We're shading it in. Are we including 6? Are we including minus 4? No. And to show we don't include minus 4, always put one of those around it, just to show you're not including it. It's running right up to it, but we're not including it because there's nothing underneath. Right. Leave insert stuff. Let's jump into it. Quadratic inequalities. So, quadratic inequalities only come up on leave insert higher level. We have the following. Solve the following inequalities for x. So 2x squared minus 5x plus 2. We get a quick little run through one of these before I get you to do. So we want to show, get the values for x in which it's less than 0. First thing first, step 1 is solve. So you can factorize it or minus it. At this stage, you have to factorize that. Alright, have to factorize that. That's 2x and x, and then that's minus 2 minus 1. Plus 2 minus 1. No, that's wrong. I factorize it now. That should be minus 2 minus 1. Let me do it over here. That changed the notes. Right, 2x squared minus 5x plus 2 is less than 0. Factorize it. That's 2x and x. We have plus 2 to get minus 5, so that's minus 2 minus 1. 2x by x, 2x squared, 2x minus 2 is minus 4, x minus 1, x minus 5, x minus 1 by minus 2. Less than 0. Then, 2x minus 1 is equal to 0. 2x is equal to 1, x is equal to what? Is that right? X is minus 2 is equal to 0, x is equal to 2. Where these are less than 0. So, if you're asked to factorize and solve it, normally you finish. When you're doing inequalities, you will step to it. And the easiest way to get this right is you draw a diagram. Now, is this positive or negative? Positive. Isn't that how we know it's positive? The number from x squared is positive. So how we know it's positive is the number from x squared is positive. This is all in the revision as well. Is this going to be U-shaped or M-shaped? U-shaped. When it's positive, it's U-shaped. So, what do these tell me again? These are roots. We're close to the x-axis. Good stuff. So, here's 2, and here is a half. U-shaped, like this, plus the x-axis, like that. Now, it asks me where it's less than 0 or greater than 0. less than 0. Less than 0 means below here. So once you get the values for in here, that means x must be greater than a half. It must be less than 2. Is that right? That little picture is very, very important to do, especially when these get hard. Is that okay? Right, we're only going to do another one of these. I want you to have one. The following question. I'll leave this one on the. Change those numbers for upload. I will go at the following question. Two x squared minus 11x plus 5 is less than 0. Off you go. Factorize it and solve it first of all, and then draw your little graph.
Different value is the bottom of the
How do you?
So it's
Right. Let's look at it then. So, 2x squared minus 11x plus 5 less than 0. Once again, factorize it less than 0. 2x and x, 5 to get minus 11. I'm going to go with minus 5 minus 1. 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to a half. X minus 5 is equal to 0. X is equal to 5, where they're less than 0. Out you come to the side, draw your little graph. Just a rough little sketch. Put your points there. There is my half. There's my 5. U-shaped or N-shaped? U. It's not always U, be careful. There's my U-shaped graph. Is it greater than 0 or less than 0? Less than 0. If it's less than 0, it's below the line, so it's inside here. If it's inside there, x is less than 5 and greater than a half. Is that okay? Right, let's do another one of these, a bit tougher. Have a go at this one. Just a small little change. Reorganize it, factorize it, and solve it. So this one was slightly different. So it was x squared minus 3x minus 10 is greater than or equal to 0. So, thanks very much. X and x minus 5 plus 2. X is equal to minus 2. And x is equal to plus 5. Is that alright? There's your graph. There's 5. There's minus 2. It's U-shaped, but there's one difference between this time and the last time. The last time it was less than 0, now it's greater than or equal to 0. Greater than or equal to 0 means above the line. If it's above the line, it's out here and out here. What that means is that x must be a number greater than or equal to 5 and less than or equal to minus 2, because you want it that way and that, because it's above them. Is that okay? See how the signs change depending on this down here.
Yeah, only inside the U.
Inside here.
Yeah.
No, it's either going to be below here or out here and up here. If it's greater than, it's up here and up here. If it's less than, it's in there. Sorry? How do you mean equal to? It's just you put the lines underneath. See, the last time I left them out, I didn't put lines underneath them. But here I put lines underneath and down here and down here. Right, let's do another one of these. Have a go at this one. Four x squared minus 9 greater than or equal to 0. Off you go. So factorize it first. this? Sorry? Difference of two squares. So remember the relation. Don't forget to draw your next sketch. There you finish the chapter. Right, let's look at it. So, difference of two squares, 2x 2b squared minus 3 squared greater than or equal to 0. That's 2x minus 3 by 2x plus 3 greater than or equal to 0. 2x is equal to 3, x is equal to 3 over 2. 2x equal to minus 3, x is equal to minus 3 over 2. So, U-shaped again. There it is. Now, is it greater than or equal to 0 or less than or equal to 0? So it's above the line. So it's out here and it's out here. That means we want x to be a number greater than or equal to 3 over 2 and less than or equal to minus 3 over 2. And that's where your symbols go. Because we want any number out this way and we want any number out that way. Is that alright? Right, these get a slight bit harder when they pop up in fraction form. This is the most common one that shows up in the leading section. Alright, this is the one they like. This is the one that comes up in the exam paper every 3 or 4 years, sometimes every 2 years. 3x plus 4 over x minus 5 is greater than or equal to 2. Multiply across 5. That is already captured on this straight away. It is not x minus 5. You are very close. That is where they catch you on this question. You do not multiply across x minus 5. And the reason you don't do it is because the very first thing I told you in the what do you multiply across 5? X minus 5 to be squared. Anyone know why is it x minus 5 to be squared? And not just simply x minus 5. Because of that. We don't know. Just say, for example, x. Just say x is only 3. What happens? That's a negative number here. And what's going to happen then? We flip. If we don't know what x is, can't multiply across 5. But we can if we say x minus 5 to the square. Why? Exactly. The squared number is always positive. So, in that case, we multiply across 5, x minus 5 to the square. That means you're left with x minus 5 times 3x minus 3x plus 4 because one of these cancels the one on the bottom. And then it's 2 times x minus 5 to the square. That is multiplication out there. 3x squared minus 15x plus 4x minus 20 greater than or equal to 2 times square the first side squared, twice the first side the second minus 10x squared the last 25. That is 3x squared minus 11x minus 20, 2x squared minus 20x plus 50, all to one side is x squared plus 9x minus 70. Once again, you bracket, x minus 5x plus 14, line down the middle, x is equal to 5, x is equal to minus 14. You draw your diagram, minus 14 and 5, and we say x is less than or equal to minus 14, but greater than 5. Why do we not say greater than or equal? Very beginning of the question they told us x equal to 5. They try to catch you doing this thing. First thing they try to catch you is you have to remember it was squared. They'd also take 3 marks off at the bottom if you didn't remember. They told you x couldn't be 5. So it can be any number up to 5, but it can't include 5. Is that fair enough? It's a fair bit of work in these. Right, I want you to have a go. Have a go at the following. Have a go. 4x minus 1 over x plus 2 less than 1. Solve that. Sorry? Yeah, x plus 2 on the top left, x plus 2 on the top right. Exactly. Right, let's look at it. So, multiply across by x2 plus 2 to be squared, x plus 2 to be squared. That is 4x minus 1 by x plus 2 is less than 1 times x plus 2 to be squared. 4x by x is 4x squared, 4x by 2 is 8x minus 1 by x is minus x minus 1 by 2 is minus 2. That's 1 times x squared plus twice the first by the second is plus 4x plus 4. 4x squared plus 8x minus x is 4x squared. 8x minus x is plus 7x minus 2 is less than x squared plus 4x plus 4. 4x squared minus x squared is 3x squared. 7x minus 4x is plus 3x. Minus 2 plus 4 is minus 6 is less than 0. Divide across by 3 to make life a bit easier. X squared plus x minus 2 less than 0. Bracket, bracket. X and x plus 2 minus 1. That is x is equal to 1. X is equal to minus 2. Over and draw your graph. There is minus 2. There's 1. U-shaped. Less than 0, greater than 0? Less than, so it's underneath the line. X, therefore, is any number less than 1 or greater than minus 2. And that is generally a 15 marker on an exam. Is that alright? Right, have another go at one of those. Have a go at this. So, question number 7. Have a go for me. X plus 3 over x minus 5 less than or equal to 0. Greater than or equal to 0. Right. Let's look at it. So that is x minus 5 to be squared, x minus 5 to be squared. We all happy with that? One of these cancels one of those. That's x minus 5 by x plus 3 greater than or equal to, that goes because it's multiplied by 0. Now, you can multiply these out and factorize them, but you're still going to end up with x minus 5 by x plus 3 because they're already in brackets for you. So you can literally put a line down the middle here. X is equal to 5 and x is equal to minus 3. So you could multiply those out, but you're going to end up with x minus 5 and x plus 3. All you're doing is multiplying them out and back up the same brackets again when you factorize them. So small little things like that can save you a bit of time. Line down the middle. There is 5 minus 3 U-shaped greater than or equal to 0. Greater than or equal to 0 means out here and out here. Line, line. That means x must be a number greater than or equal to 5 and less than or equal to minus 3. Is that right? Right, last little thing for today before we head out the gap. These can come up a small bit tougher. They can come up the following. Abstract inequality. So, prove the following abstract inequality to be true. So we have to prove, we don't know what x and y is, but we have to prove somehow that x squared plus 2xy plus 2y squared is greater than or equal to 0. Anyone have any notion? You don't split that, not actually double inequality. Double inequality is two inequalities. Anyways, take a wild guess there. What do you reckon it is? Square root. Not square root. Can't bring x squared to one side. There would be some other thing, but see, we're stuck here with. Let something equal to 0. No, that's not wrong. What these actually are, and they do come up with, is it's some type of factorizing. They do come up, and they come up in isolate. They usually come up with A's and B's and exam papers. And when they pop up, it's literally, you have to kind of remember that you're factorizing this somewhere. Is that right? So like they come up like that, or it's not B squared greater than 0. And it comes up looking kind of something like that. It involves some form of factorizing. So there's some form of factorizing that you have to do to prove the inequality. And the factorizing that's here was actually that's some form of trinomial, i.e. we're going to look at bracket, bracket. So I'm going to put in two brackets like that. Anyone know how we get two brackets. So I'm going to give you that. Really, there it is. 1 minute. Anyone see it? It's all about being able to see it. What? Not 2 and y. No. That should be y squared. That should be 2y squared. Change that. That should read like this. Apologies. 2 mistakes, please. That should read x squared plus 2xy plus y squared greater than 0. It should read like that. We have to be able to spot that that was xx, yy, which gives you, and it was, plus plus x by x, x squared, plus xy, plus xy, plus y squared, which is x squared, plus 2xy, plus y squared greater than 0. Sorry, how about that? I put on the question on. That's my fault. Since the last, I wrote down the question on. I do a lot of loss, I guess. I wrote down the question on. It's my own fault. Right. Back to this one. That's factorized there like that. That's x plus y by x plus y is greater than equal to 0. Anyone know how I finish this off by proving that's greater than equal to 0? That's it. X plus y, the bracket is squared is greater than equal to 0. Y and t squared is greater than equal to 0. We're going to start with those the next day and we're going to do the revision exam items. See you next Friday, boys, right? Let's fix those notes. See you, boys. Myself.